Welcome to Section 7.4. In Section 7.4, we're going to look at more multiplication properties of exponents. For a warm-up, let's review what we did in the last section, drawing a line from each expression in column A to its simplified form in column B. Let's see how you did. Remember our rule from last section. Keep your base and add your exponents. So 5 and 3 would give us 8. 6, and remember there's a 1 here, 6 and 1 would give us 7. And 4 and 11 would give us 15. Our vocabulary word today is simplify. We can simplify an expression to make it less complicated. So, let's see if we can figure out the pattern in these examples. Here we have 2 to the third to the second power. So that means we're taking this quantity in here and writing it 2 times. So 2 to the third times 2 to the third. Well, 2 to the third means 3 2's. 3 more 2's here for the second 2 to the third. So all total, how many 2's do we have? 6. This time we're writing 2 to the second 3 times. So we need 2 2's for the first 2 to the second, 2 2's for the second, and 2 2's for the third. So here again, we have 2 to the 6th power. Here, we're going to write 4 to the 2nd power 4 times. So we're going to need 4's, another pair of 4's, another pair of 4's, and a final pair of 4's to give us a grand total of 8 4's. And in the last example here, we are going to write 3 to the 4th twice. So we're going to need 4 3's, 4 more 3's, for a grand total of 8 3's. Here I would need to write 6 to the third 4 times. So we would have 1, 2, 3, 4, 5, 6 for the second group, 7, 8, 9 for the third group, and 9, let's count, 10, 11, and 12 for the last group. So all total, 6 to the 12th. Do you notice a rule for this pattern? Hopefully you notice that you're multiplying the exponents. So if we look here, if I erase my mark there, we are taking the 2 times the 3 to get our 6. The 2 times the 3 here to get our 6. Here we had 4 times 2 to get 8, 4 times 2 to get 8, and 3 times 4 to get 12. So our rule for what's called power to a power is to multiply the exponents. So we keep the base and we multiply the exponents. So look here, we have 4 to the 2, 4 squared to the third power. So that's going to give us 4 to the 6th. Here we have w to the 5th squared, which is going to give us w to the 10th. 5 to the 4th raised to the second power is going to give us 5 to the 8th. And m to the 3 to the third raised to the 5th power is going to give us m to the 15. Again, raising a power to another power means you're going to keep your base and multiply your exponents. For example, 2 to the third squared is 2 to the 6th. M to the 4th raised to the third power is m to the 12th. Let's take a look and figure out the simplified form for p to the 5th raised to the 4th power. First of all, to simplify p to the 5th raised to the 4th power, are we going to add or multiply the exponents? We're going to multiply them. Circle the expression that is equivalent to p to the 5th to the 4th power. Remember what this means. We are going to take whatever's in here and write it 4 times. So that's p to the 5th, p to the 5th, p to the 5th, and another p to the 5th. So the simplified form is going to be p to the 20th, multiplying those exponents. Try these examples on your own and check back to see how you did. Let's look at the first one here. Here we have s to the 10th, 10 to the 5th, and notice in this last one you actually have 2 separate problems. You take care of this problem first and then this problem. So here you would have p to the 7th, here you would have q to the 15th, and that's as far as you can go with this problem. Let's take a look at this example. Here we have h to the second. Here we have 7 times 0, which is going to be 0. And now we're going to multiply like we did in the last section, keeping our base and adding our exponent. We could also have done this saying that this is h squared, anything to the 0 power is 1, so h squared times 1 is h squared. Let's compare using greater than, less than, or equal to. On this side, our exponent would be 6, and on this side, our exponent would be 6, so those are going to be equal. Here we have 3 times 0, which is 0. Here we have 0 times 4, which is 0. Anything to the 0 power is 1, so these are going to be equal. Here we have negative 2 times 3, which is a negative 6. And here we have negative 3 times negative 2, which is a positive 6. So the positive 6 is going to win out on that one. And here we have a negative 3 versus a negative 4. The negative 3 is going to win out on that one. Let's take a look at the simplified form for x squared times x to the 6th to the negative 4th. So first, you're going to multiply the exponents for the power to a power. You're going to take care of this part first. So x squared is going to stay x to the negative 24. Now we're back to where we were, in the last section. X squared times x to the negative 24th. We're going to keep our base x, and we're going to add the exponents, so negative 22. Now, we don't want to have a negative exponent, so we're going to rewrite that as 1 over x to the 22nd. Homework for this section is on page 436, numbers 10 through 21.